All right, so this is a brief review of section 3 from chapter 1. Chapter 1 in the book in section 3 is on exponents. And these are, again, concepts that if you took high school algebra, you will be very familiar with. These are basic mathematical principles involving exponents. So, for instance, 2 times 2 times 2, which is 8, can also be written as 2 to the third power. And if we have even a mix of numbers, 2 times 2 times 3 times 3 times 3 times 3 can be rewritten as 2 to the second power and 3 to the fourth power. 1, 2, 3, 4 of those. And in fact, we have this principle in broader terms, x to the nth power times x to the nth power. This principle is very important throughout the entire course. This is x to the n plus m. And this principle here will show up over and over and over again throughout the semester, especially in chapters 5 and 6 and 7 especially. And so we're covering the first 7 chapters of this book. Right now we're laying the groundwork for some basic principles that we use throughout the book. And this is one of the most important. Another one like it is the aspect of dividing terms like that. So we have 2 times 2 times 2 divided by 2 times 2. Now normally the way we would do this in mathematics is we would simplify this fraction by canceling out common terms, which would leave us with the number 2. As you see, those two 2's would cancel those couple of 2's, and we'd be left with 2. But if we write this exponentially in an exponential format, 2 to the third divided by 2 to the second, well, in the way this would work is 2 of the 2's would cancel with 2 of the 2's there, leaving us 2 to the first power. And 2 to the first power, or any number to the first power, is the number itself, and we get the number 2 back. And this leads us to this principle here, that x to the nth power divided by x to the mth power is x to the n minus m. Now, one other fundamental principle that's important in all this, because this will show up from time to time as well, is that if you have, for instance, 2 divided by 2, and those cancel, and we subtract, this is 2 to the first power, 2 to the first power. If you subtract 1 minus 1, you'll get 0. 2 to the 0th power. And any number to the power of 0 is the number 1. So 2 to the 0th power is 1. And broader speaking, any number, x to the 0th power, is always 1. And this will show up again and again throughout the semester, especially again in chapter 7, where something to the 0th power will materialize from time to time. Okay, so this is some of the basic ideas. Now let's work a couple of problems using these fundamental principles of exponents. Let's work a couple of problems that relate to that. So, for instance, we could have the problem a to the 5th times a to the 3rd. Now, using that principle of multiplying terms, the same term, to various exponents, powers, we would then add those two. We'd say a to the 5 plus 3, which is 8, a to the 8th. Now, if we were to divide them, and we had a to the 5th divided by a to the 3rd, this would be 5 minus 3, a to the 2nd power. Another example of this involves where exponents can be written in negative. It's fine to have an exponent negative power. For instance, x minus 5 times x minus 8, for instance. Now remember, the product rule with exponents is that you would add minus 5 to minus 8. If you add minus 5 plus a minus 8, you get minus 13. That's x to the minus 13th power. And this leads us to another basic principle of exponents, is that x to the minus n is equal to 1 over x to the n. So in this case, x to the minus 13th power is the same thing as 1 over x to the 13th power. Yet again, another principle that will materialize throughout the semester over and over and over again, especially in chapters 5, 6, and 7. These principles of negative exponents, and mathematicians are kind of quirky people. They don't like, oftentimes, they don't necessarily like having a final answer where there's negative exponents. A lot of times, in algebra at least, they'll ask you to rewrite the answer so that no negative exponents remain. So for instance, if you had something relatively simple like this, x to the minus 3 divided by y to the minus 2, now you see that those are two different terms, x and y. You can't combine those. X is different than y, clearly. I mean, you can substitute in a variety of numbers there. You can't just simply combine this into one term. But you can rewrite them and get rid of those negative exponents. Y to the minus 2 down here in the denominator now is y to the second written in the numerator. The numerator is on top, denominator on the bottom. Way to remember that is that you get common denominators. You get common denominators, the bottom of the fraction, where when you're adding fractions together, you need common terms in the bottom to be able to add them. Common denominator. The denominator's in the bottom. So y to the minus 2 in the denominator is now written as y to the second power, now written in the numerator. That negative sign, written as a positive, pushes that y term into the numerator. And the same true about the numerator on this side. X to the minus 3 now becomes x to the third written in the denominator. Okay, so this is the exact same fraction, one written with negative exponents, one written with positive exponents. And so the ability to combine these terms and to do so fairly quickly will be very helpful throughout the semester. So the best thing to do is practice a lot of these problems in section 3, because the manipulation of particular fractions or manipulation of even whole equations where these exponents of common terms are being combined somehow, that is a very helpful tool. Now there's another principle in here as well, and that is what happens when you have exponents with exponents. So something like this, x squared to the third power. X squared to the third power. Well, that is equal to x second power times 3. So x to the second power with a 2 times 3. This exponent rule, so that's x to the 6th power. And the broad principle is this, x to the n, all to the mth power is x to the n times m, written something like that. And so here in this case we have x squared all to the third power. That's x 2 times 3. This times that is 6 to the x to the 6th power. Now let's do one a bit more complicated problem then with all of this. Let's suppose we have a problem that looks like this: a to the minus 2, b to the third power, divided by a squared, a cubed, and b to the 4th. And let's suppose we take this whole thing and write it to the 4th power. Okay? So that's a mess, or at least it looks like a mess, but we're going to clean it up here. The first thing we can do, first of all, is we're going to work inside this parenthesis for just a minute, and we can pull that a to the minus 2, we can pull that down here and write that as a squared. So we're going to be left with b to the third, a squared times a to the third, b to the 4th. Now the next thing we can do is combine these a terms here. Remember, when you're multiplying exponents, all of that to the 4th power. When you're multiplying same term to exponents, you add them together. So that's 2 plus 2 plus 3, that's 7. So this is going to equal a to the 7th power. In addition to that, though, we have b to the third and b to the 4th, so we're going to subtract. 3 minus 4 is minus 1. That's going to leave us with b to the 1st power in the denominator. You see how there's 4 down here and 3 up there? That will leave us just 1 left here when these things cancel out, this whole thing to the 4th power. And now writing this to the 4th power, well, 1 to the 4th power, 1 to any power is 1. And then in the bottom, remember, we're going to multiply 7 times 4. That's a to the 28th times b to the 4th. 4 times 1. And so our final answer looks like that. So we get from this rather messy looking thing to a very simple outcome, 1 over a to the 23rd, b to the 4th. And this is very common in algebra. Algebra teachers, algebra textbooks like providing you something fairly complicated up front, and then by the time you get to the end, it's a fairly simple fraction, or it's simplified pretty dramatically. And for whatever reason, math people like that kind of thing. They like complicated problems that then, by the time you're done, it cancels out, and you wind up with the number 2, or you wind up with one variable left, or something like that. And so this is an example of that kind of thing, which is true throughout the whole book. You start with what looks like a fairly complicated problem. But by the time you do all the operations of exponents and canceling terms out and other rules of general mathematics and so forth, you wind up with a fairly simple solution. So now the rules of the properties of exponents are written on page 304. There's a box there with these properties, and I've shown you several of them already. Let's work one more problem just for fun. Let's see. Let's do the following simplification. This is one of the extra practice problems, and I'll pick this one here. We have let's see, c cubed, all of that squared, and then we have c to the 4th to the minus 2. So we're told in the book that we should simplify this. So we're going to work with each individual exponent first. C to the 3rd, all to the power of 2. When you have an exponent to an exponent, remember you multiply. So that's c, 3 times 2 is 6 times. Now c to the 4 to the minus 2, you multiply. 4 times minus 2. 4 times minus 2 is minus 8. That's c to the minus 8. Now we have the product rule going on here. Product of 2 terms with exponents is we add those. And that's going to get a c to the minus 2. Now yet again, mathematicians don't like necessarily, especially in this algebra book and in intermediate algebra, writing final answers with negative exponents. So they would have you write this as a fraction. And the way we would do this is 1 over c squared. C to the minus 2 is 1 over c squared. And so that's how you would manipulate those numbers, those terms in order to generate a fairly simple outcome. So we start with a kind of a complicated set of information, c to the 3rd all squared, c to the 4th to the minus 2 power, but by the time we're all done, it's 1 over c squared, a fairly simple looking term at the end. So that's how problems in this section, chapter 1, section 3, are done.